you're going to be asked to do in this chapter is you're going to be asked to do about Pythagoras' theorem. Pythagoras' theorem only exists when there is a right angle triangle. And the deal is with Pythagoras' theorem is that you'll be given two sides and you'll be asked to get the third side. Okay? So case in point, this example here, where x is the longest side and 3 and 4 are the other two sides. What you do is the longest side squared equals the two shorter sides squared, and then added together. In a second we do. X squared equals, you put this into your calculator, you're going to get 9 plus 16. X squared equals 25. Then, as Joe rightly said, you square root it, and you get x equals 5. Is that okay? Longest side squared equals the two other sides squared and added together. Then you square root the answer. You can be asked a slightly different variant of this as well. You can be asked, you're given the longest side. Imagine you're given that as 10. And you're given one of the other sides and you're asked to find, let's call this y. In this case, guys, which one's the longest side? Still 10, so it's 10 squared equals 6 squared plus y squared. 100 will equal 36 plus, I'm sorry, spoiling it there. 36 plus y squared. What does y squared have to be to make that happen? 64. And y therefore must be 8. They're the two possible Pythagoras theorem questions that could come up. Okay? Now, we're going to use Pythagoras theorem to answer this here. What I'm going to say is this length x squared equals 100 squared plus 240 squared. I'll go straight to my calculator. I will do 100 squared plus 240 squared straight away. Oh wait. No idea what happened there. Oh, what's going on there? 240 squared. Okay. 676,000, yeah? So x squared equals 67,600. Square root that. What you get, Joe?
I got 260.
Yeah, 260. That seems about right. Everybody alright with that? Okay. Now, that's 260. Now we're going to look across and see. Simon travels A to C on his quad bike. He can travel on the road from A to B to C at an average speed of 72 kilometers an hour. How long will the journey take? If you ask me, that's 340 meters. Would you agree with that? What's 340 meters in kilometers? 0.34 kilometers. How would you calculate time? Yeah. Sorry? Yeah, distance over speed, yeah. So time equals distance over speed. Okay. Which is 0.34 divided by what, guys? How fast do you have to go? 72. Put that into the calculator. 0.34 divided by 72. And long behold, you get 0 hours, 0 minutes, 17 seconds. So, anybody else in class get 17 seconds? Okay, did you use that calculator technique? Excellent. Now, use the theorem of Pythagoras to find the length of A to C. Already done. Simon can travel in a straight line from A to C on his quad bike over rough ground. On rough ground, he can go 48 kilometers an hour. So, time equals distance divided by speed. What's your distance? 260 meters. What's 260 meters in kilometers? 0.26. What speed is he going? 48. Do the same trick again. 0.26 divided by your 48. And press your button. He's going to do that in 19.5 seconds.
Yeah.
Is that okay? What's the time difference then? Which way is quicker? stay on the road and go 340 meters. Okay, cool. Move on. Move on. Okay. 15, yeah? Was I meant to do 13? That'd be grand. 15. In a journey of 235 kilometers, a man drives for 2 hours at an average speed of 80 kilometers an hour. How long did the journey take? What? Oh, the remainder of his journey. Okay. So he's 235. How much distance did he cover at 80 kilometers an hour? 80 multiplied by 2? 160. How much distance remains? What? 75 kilometers remaining. Time equals distance over speed. He's going to cover this 75 kilometers at what speed? 50. How long is that going to take him? 1 hour and 30 minutes when you use the calculator. How long did the journey take in total?
3 hours, 30 minutes.
3 hours and 30 minutes. That was a much easier one. Okay, move on. 17. We have a 300-meter wide pool. We have a random swimmer guy. There we go, it's not bad. Now, yes. Very happy about that. Little things, lads. Now, damn. 300 meters. Okay. It takes, we want a speed. Speed is distance over time. He did 300 meters in 200 seconds. How fast was he going? 1.5 meters per second. Okay, on the way back, how fast was he going? Because you got to divide 300. Now, he does it in 4 minutes and 10 seconds. We're going to convert that into seconds. So what is that in seconds? 250 seconds. And what did you get for that? 1.2 meters per second. Now, his real speed is somewhere in the middle, isn't it? Because on the way up, he's assisted by the river. And on the way back, the river works against him, doesn't it? So here's what we're going to find. Find the difference in the speeds. What's the difference in the speeds? 0.3. Find U speed when swimming in still water. It's actually the average of both speeds. It's the average of you with the river plus the average of you without the river. So what happens when you add the two of them together? Divide 2 by 7 by 2? 1.35. Now finally, guys, how fast was the water then? If you go 1.5 with the water, how fast was the water? 0.15. Good job. How many people got this one out? Hey, come on. Now, move on. Okay. Yeah.
I got that.
So, just to hit this point home, there is a bit of misunderstanding going on. So get this, guys, all right? Imagine I had a 10 kilometer an hour wind, similar to the river, yeah? And my car can go 80 kilometers an hour. How fast can I go down the road if the wind is on my back? 90. How fast can I go on the way back? 70. Out of interest, what's the average between 90 and 70? 80. So the average gives you the average will give you the actual velocity. When you calculate the average, all you have to do then is look at the average and look at the maximum, and you gain 10 kilometers an hour. So you can tell that the speed of the wind was 10 kilometers an hour. We're going to do that same trick. We're going to do that same trick with the river. Okay? We're going to say that with the river we were 1.5. Against the river we were 1.2. We get the average. The average was 1.35. That means I can only swim 1.35 in perfect conditions. Then we examine the 1.35 and compare it to the 1.5. We realize that it's 0.15 bigger. So that means your river must have contributed the 0.15. Okay? Excellent. Move on. This one is going to require us to use our calculator, okay, and use it in scientific notation. It's also going to require us to change. Why do I have to change 8 minutes into 480 seconds? Because it's kilometers per second. Okay? Next thing. Distance. Distance equals speed multiplied by time. Your speed is 2.9 by 10 to the 5. Your time is 480. Anybody have an answer for me? I'll take that as a no.
1,392 multiplied by 10 to the power 5.
Really?
No.
1.393.
1,000.
Whoa. Okay. Anybody remember to do this?
Yeah.
Keep dividing by 10 until we get the answer, okay? So wait for this. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. So 1.392 by 10 to the 8. Is that okay with you guys? Happy enough with that?
I knew that was an answer.
Now, I kept this hidden from you, but get this. If you go to Shift Setup, see Science Mode,
Yeah.
7. Kept this hidden because I want you to understand it. Press 0. Do the same question in your calculator again. And all of a sudden, you don't have to do a thing. 1.392 by 10 to the 8. Now guys, the reason why I taught you the other way was if you happen to forget the mode on the day, there's a backup plan. Okay? So one more time. Shift, Setup, Science Mode 0. And that's your answer. To get your calculator back to working normally, Shift, Setup, opposite science is normal mode. 8, 1. And then it changes it back. Don't. Okay, move on. It's on video anyway. Now, shh. Next one. A train travels 168 kilometers at a speed of 112 kilometers an hour and then travels 45 minutes at an average speed of 100 kilometers an hour. Calculate the following, the total distance traveled. Okay, distance equals what, guys? Speed by time. 100 kilometers an hour multiplied by 0 hours and 45 minutes. Or, according to my calculator, 0 hours, 45 minutes, 75. Are we cool with that? 75 kilometers. How far did we travel in the first case? What is that then? 243 kilometers. Shh. The total time taken. We know he took 45 minutes in the second half of his journey. We don't know how long the first half of his journey took. So time equals what, guys? Distance divided by speed. Shh. 168 divided by 112. 1 hour and 30 minutes. Okay, add them together. 1 hour 30 plus 45 plus 0 hours 45 minutes. 2 hours and 15 minutes. The average speed for the whole journey.
32.
Okay, average speed is speed equals what, guys?
Distance divided by time.
Distance divided by time. Now, if you put this in, I don't think it's going to go unevenly. Hopefully it doesn't. I want to see one that doesn't go unevenly. Now, 108. Happy enough with that?
That's 30. Oh, that's 22. Look.
Yeah.
I got.
Let's go. 24. Jack cycled his bike in the following manner, and we got to figure out some of the questions there, okay? So, he starts off with 0, 0. What does 0, 0 mean? No time, no distance traveled. Can anyone in class explain to me what does 30-10 mean? 30 minutes traveled. 30 minutes used, 10 kilometers traveled. How long did it take him to complete 8 kilometers? 8 kilometers, guys. What do we get?
28.
Okay, look up, guys. There's 5 blocks for every 15. Each block must be worth 3. 18, 21, 24. You have a question? Next one, 12 kilometers, guys. What about 12 kilometers? Yes, sir. In the corner. 36 minutes. No, 39. I could be slightly off though, am I?
No, 37.
It has to be a multiple of 3, I'd say. 39. The distance Jack will cycle in 17 minutes. How are we on to 17 minutes? Oh, we have to use the graph. Oh, that's really difficult. That's a poor choice of question. Okay, so I'll show you now. Okay, guys. If you were to look at this, okay, if you were to zone in, directly beside 15 would be 18. So you want to go close to 18, but not too close to 18. And it's a rough estimate at best. I'd say 5.5 kilometers, roughly. Yeah, it's okay if you're slightly off. I'd say halfway between 5 and 6. Lads, 51 minutes. That's 48. This one's 51 on the money, which is great. 51 on the money. Go straight up. Whoa, that is not anything but straight up. Okay, let's try again. Straight up. Sorry, straight across. I'd say about 15. Write a formula for the distance travelled, y kilometers an hour, required for a journey taken x minutes. Okay, guys. Excuse me, guys. The x variable is the time. What they're basically asking you is, what's the maximum and minimum distance you could cover if your time is less than 30 minutes? So let's go to 30 minutes and figure this out. Okay. So how far did we travel after 30 minutes? Anybody care to tell me? 10 kilometers. I would say your y value has to be beneath 10 kilometers. Why? Because if you're only traveling for 30 minutes or less, you have to travel less than 10 kilometers. What happens if your time is more than 30 minutes? What then? The distance you covered must be? Huh? Greater than 10. Alright? Okay, great. Alright, gents.